Welcome to Applying Sensors to Improve Vehicle Reliability, Make Repairs Easier, and Boost Productivity. I'm Will Healy, Industry Strategy Manager for the Americas, and I'm here to talk to you about mobile equipment and how sensors and other technologies are being applied to mobile equipment. So when we look at whatever it is, whether it's an agriculture machine or a fire truck or a piece of construction or mining equipment, even something used for access or lift, these pieces of equipment need sensors to be able to execute the automation reliably, and they have to have rugged and industrial qualities to them to be able to survive in the environments that the vehicles work in every day. So today I want to talk about applications for vehicle reliability, and I'm going to focus on two different areas. I'm going to start with sensor applications, and I'm going to move on to some other specialty applications through this presentation. So the sensor applications I'm going to talk about today are position detection, smart cylinders, material level control, collision avoidance, hydraulic system monitoring, and tilt level angle position. The specialty applications I'm going to talk about are traceability, RFID, vision cameras, connectivity, and accessories. So let's dive in. I got this great counter and we're going to check it out. So first, the position detection applications. These kinds of applications are things typically like, is an engine compartment open or closed? What is the slewing position of a crane or a boom? And then other applications that are similar to that. So typically inductive proxies are used for those applications like you see here, or inductive proxies here. Typical sizes that we see are M30 and M18, but you also see the Q40 block style housing because it gives you a nice sensing range and a little bit more compact and versatile mounting configuration. These are really nice because you can actually change the position based upon the mount in 5 different directions. So you have a lot of options for how you mount the sensor versus a tubular proxy. You really have only one direction you can mount the sensor. So a bunch of different options for detection. What we're showing here with this demo is actually the ability of a BMF magnetic cylinder sensor. The magnetic sensor here actually uses a magnet as a target instead of a metal object, but it can get a much longer sensing range than the inductive prox can. So this is an M18 unshielded prox, which usually has a good sensing range of 16 millimeters, and we can get anywhere close to 80 millimeters out of a magnetic field sensor that's even smaller with a magnet. So if you're having applications where you need a little bit longer range and a prox isn't cutting it, a magnetic field sensor might be the opportunity for you. The next application I want to talk about is smart cylinders. With smart cylinders, we can do applications like outrigger, the position of the outrigger and where the outrigger foot is positioned. This allows us to balance and level the truck. Or applications like on a drilling rig, the position of the hydraulic cylinder controls the angle of the drill. And so with a smart cylinder, there are a couple ways to do it. But one of the main ways that we have is the linear position transducer. This gets mounted in the cylinder. The cylinder's gun drilled, and the magnet is mounted on the piston. The magnet moves back and forth with the piston and allows you to control the position, closed loop control the position of the hydraulic cylinder. Just like the muscles and nerves work together in your arm to do closed loop control for your arm, we're able to use the sensor to provide closed loop control of a hydraulic cylinder. The other option is to use a high pressure inductive prox and embed that in the cylinder, and that gives you just discrete end of stroke positions. So maybe you want to make sure something's completely extended, or more importantly, something's completely retracted before the vehicle moves. We can embed this in the end of a hydraulic cylinder and just give you a discrete on-off position. Is the cylinder completely retracted? The third application we're going to talk about is material level control. This could be something like spraying material, like a fertilizer, a liquid fertilizer on a field sprayer. We can use a capacitive sensor for that. This is an analog. In the PowerPoint slide you see an analog position capacitive, but here on the demo you can see a point level capacitive sensor that'll just give you a high, low, medium kind of application. So there's a lot of ways to detect the tank level. You can also use a pressure, like in this fire truck, we can actually monitor the pressure in a tank. If we put the pressure sensor at the bottom, we can use something called hydrostatic pressure to monitor how much fluid is actually in the tank on the vehicle. The next application we're going to talk about is collision avoidance. With collision avoidance, it could be things like in a combine harvester to make sure that the harvester doesn't actually impact the ground, that we're maintaining a proper height off the ground. Or like these stairs in an airport, as we approach the airplane, we don't actually want to make contact with the airplane. So the technology that we most typically see in use is the ultrasonic sensor that you see here. The ultrasonic sensor uses sound waves to actually detect the presence and can provide an analog position value, 4 to 20 milliamp analog position value, that actually gives you the information about how close are you to the object. So that's a really great option, using sound waves to actually detect the position and proximity to an object. The fifth application I'm going to talk about is hydraulic system monitoring. Over here you can see the linear position transducer again. We can use this with a float to detect how much oil's in the hydraulic power unit storage tank. We have pressure transducers. You can see here that actually will give us the amount of pressure that's available. Some people will use that actually on a cylinder to detect position based upon pressure, but you can also use the pressure just for the system monitoring itself. And then of course you have valve manifold connectors for controlling open and close the valves of a hydraulic system, as well as the high pressure proxies about the cylinder position like we talked about, or you can use it for valve position as well. So you see lots of different applications there. The sixth application we're going to talk about is tilt or level angle position, and for that we use inclination sensors. An inclination sensor can be used for something like an access platform or a apple picking platform like you see here. Anything where we have to have a level platform on a bucket truck, something like that, or even on a boom truck or a crane truck where we have to have outrigger leveling, right? We have to make sure that the truck is level before the boom of the crane is extended. And so we have an inclination sensor here showing actually two directions, so we can get a really good orientation of the vehicle in two different axes, in the X and the Y direction, to be able to tell us how level are we in relation to the vehicle and to the ground. So I mentioned that there are a few other specialty applications that we're going to talk about. I want to talk about traceability and RFID. The two applications I want to mention are the ability to detect attachments. This is an application where we can actually use RFID to tag the attachments. We can know how many hours of use they've had, if they've got to have some repair or maintenance cycles. Maybe you have to replace consumables on the end of the attachment every so many hours. The RFID can be used to detect, are we holding the right attachment, and we can control service life and information about the attachment. The second application I want to talk about is in like a fire truck or anything where you have to keep the tools in place. You have to make sure you have the right tools, and again about service hours, or if you have to maintain any equipment, we can use RFID to detect, is the equipment present before we leave, and is the equipment ready to be utilized. For vision, there's some great applications for vision that can be used. The first one's in robotic agriculture. We see the most using matrix vision cameras, and these can be used for row detection or swale detection. We can use it for detecting targets or weeds. There are lots of things that a machine vision system can be utilized for on robotic agriculture. And then on a drill rig or any kind of big crane or any big vehicle that we have to drive, blind spot hazard detection, collision avoidance, anytime you can use a camera to provide feedback to the driver so as to avoid hazards or collisions. I want to point out one accessory. This accessory is really interesting. It's our quick change mount with positive stop. This allows for easier repair on site, because a lot of people are challenged with actually, when we have to replace a prox, we're challenged with making sure the prox is installed to the proper gap distance. And so the quick change prox mount, what it allows us to do is it allows us to set permanently the gap distance for the sensor, and then all they have to do is quick change a nut, take out the sensor, put in a new sensor, and quick change the nut, and the sensor is gapped perfectly every time to the right distance for the application. So we don't have to replace the sensor, move the equipment, damage the sensor, and put a brand new sensor in its place again. We have the opportunity to set the gap right the first time, and that way repairs are very easy in the field and on site. Last but not least is connectivity. All these sensors need to be connected together. Balluff has the opportunity and capability to add automotive style connectors like a Deutsch connector or a AMP Super Seal connector to a sensor. That's something that we have the capability to do, so contact us if that's something you're interested in. But we have a wide range of connectivity products that are available. You can see here on the demo PUR cables of a couple of varieties, shielded and non-shielded, multiple different poles, but straight and right angle. But these M12 cables are very common, but this PUR is non-hydroscopic, so it doesn't absorb water, and it has a 2 million flex cycle rating, so it's a nice PUR cable to be able to use in mobile equipment applications. What we're also showing is high durability cables. If you have a place where a cable keeps getting damaged, but you need the cable out of a conduit, you can actually use this stainless braid cable. So you can see it has a special external jacket on it that's a stainless braid that protects it from abrasion and mechanical contact. Then we have valve manifold connectors of all different varieties and splitter versions that are available. This allows us to connect to valves and control outputs on the machine. And then if you're running a can open system with your ECU, we have can open cables to communicate with the can open devices on the equipment. Also, we'll see a lot field attachables in the market, as well as passive interface blocks are used to collect sensors and valve connections together and then run them back to the controller of the machine. So if you are using interface blocks or are interested in that technology, Balluff has those as well. So today we talked about a lot of different applications for mobile equipment, but regardless of whether it's a combine or a harvester or a piece of construction and mining equipment, a fire truck like you see here, the opportunities are really there for sensors to provide for reliability and feedback in automation applications on mobile equipment. Thank you very much for attending our presentation on applying sensors to improve vehicle reliability, make repairs easier, and boost productivity. I'm Will Healy. Thanks.